Alright, lesson 1-4, part 2. So to measure an angle, we have to use a tool called a protractor. And if you were in the classroom, I would hand each of you a protractor and have a picture of an angle on a piece of paper, and you would be able to measure it. But since we don't have that option, here's a picture of a variety of angles, and there's a protractor positioned on top of the angles so that we can measure them. And if you'll notice, along the bottom here, you can see a vertex K. That's the vertex of all of the angles. And so we have a ray coming out here towards point N. We have a ray going up to M, a ray up to J, a ray KL, and a ray KH. So all of those are different rays, and they make up a whole bunch of different angles. Now, the protractor is lined up so that the vertex is in the center of this hole in the protractor. And then one edge of an angle, one side of an angle, is lined up at either 0 degrees or 180. And you'll notice over here on the other side, it's 0 on the outside and 180 here. So we show all the different degrees on the inside. We start here with 0, and you go around up here to 90 degrees, where it's a right angle, and then on around to 180. Or you could start at this end and have 0 on the outside, and you go around, and it measures to 180 this way. So let's take a look at some ways that we can figure out the measure. Determine the measures of each of the angles and classify them as acute, obtuse, right, or straight. So we want to start with angle LKN. Well, K is the vertex. Again, vertex is always in the middle. And the sides of that angle, let me see if I can find my highlighter tool. Okay, the sides of that angle are angle KL, so starting at K, going out here to L, and KN, starting at K and going to N. Now, you can see in here, this side KN is at the bottom, and it's either at 0 degrees or 180. We're going to start at 0 degrees, and if we look at the measurement, it goes all the way around. There's 0, 10 degrees, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. Goes all the way around here to halfway between 140 and 150. So that means the measure of that angle is 145 degrees. And that would be an obtuse angle, because it's between 90 and 180. Okay, now we want angle JKL. Again, K is the vertex, and the sides are KJ, so here's straight up, and the other side is KL. Now, neither one of those sides starts at 0 degrees, but we can still calculate the measure of that by subtraction. This side of the angle comes out at 145 degrees. We already talked about that. It was right here. Okay? This side is going straight up to 90 degrees. So that means this angle measurement is 145 minus 90 degrees. And when you subtract that, you get 55 degrees. So that's the measure of that angle. And its classification is acute. Now the last option, the last one, angle JKN. So again, vertex is K. Use a different color this time. And we've got ray KJ. There's one side of my angle. And ray KN. is the other side of the angle. And so here we have KN is here at 0 degrees, and KJ is at 90 degrees, and so if we subtract those, 90 minus 0 is 0. So it's a 90-degree angle, which is a right angle. All right, congruent angles, we've heard the word congruent before. It just means they have the same measure. And so a way we could write this is we could say that angle A is congruent to angle B. And when we did segments, remember we put little tick marks on segments if they were equal? Well, here, for angles, we use an arc. So you see that little curved arc in each of those? An arc denotes that angles are congruent. And sometimes if you have more than one set of congruent angles in a drawing, sometimes you can use 2 arcs. If you put 2 arcs in each of them, still means they're congruent. All right. The next thing is the angle addition postulate. And the angle addition postulate is very, very similar to the segment addition postulate. If you have a point in the middle of an angle and there's a ray that goes through that point, then it's going to divide the big angle into 2 smaller angles. So angle AOC would be this angle right here, okay? So that's what we call like the whole angle. That's one big angle. Sorry, messed up that word whole. And so if B is in the middle of it, this ray splits that whole angle into 2 smaller angles that we can call the parts. So this first part is actually called angle AOB. So the measure of angle AOB plus the measure of angle BOC is going to equal the measure of angle AOC. That would be part plus part equals whole, just like we did for the segments. So a very simple example would be, see if I can write something small in here. If this is a 30-degree angle and this is a 70-degree angle, then the whole thing would be 100 degrees. So let's use that concept to do a couple of problems. Example 4. If measure of angle QST is 99 degrees, find the measure of angle RST. Okay, so QST, S is the vertex, starts at Q, goes to T, so we're talking about QST. Okay, that whole thing from there to there is 99 degrees. If we were to take a protractor and measure that, that would be a 99-degree angle. Okay, we know that this angle QRS or QST is 52 degrees. And so that's one of the parts. And we want to figure out what this part is. Angle RST. Well, this angle, 52 degrees, plus this one has to equal 90. So how can you find angle RST? You have to do 99 minus 52. And when you do the subtraction of that, you get 47 degrees. And also, notice here it says find the measure of angle RST. So actual proper notation for that, instead of writing out the word measure, we can put a little script M in front of the angle symbol, and so that just means the measure of angle RST. Okay, we have one more example. Oh, where'd it go? There it is. Example 5. Given that KLM is a straight angle, find measure of angle KLN and measure of angle NLM. All right, KLM. Let's identify where that is. Use a highlighter. So L is the vertex. KLM is actually that entire straight line. And on the previous page, we talked about how the measure of a straight angle is 180 degrees. We want to find KLN. KLN would be this angle, and we want to find NLM, this one. Okay, so those have variables in it, variable expressions. So we're going to have to do some algebra to find those measurements. We've got to figure out what x is before we can find the actual angle measurements. So again, it's just like segment addition postulate. We've got the two parts, and we know that the whole thing is that straight angle, which is 180 degrees. So part 10x minus 5 plus the other part 4x plus 3 equals the whole amount, which was the 180 degrees, because together they make a straight angle. Now remember, this is where you've got to be careful with your algebra. Those are on the same side of the equal sign, so we have to combine like terms. 14x, combine your constant terms together. Negative 5 plus 3 is negative 2, equals 180. Add 2 to both sides. You get 14x equals 182. Divide both sides by 14. X is equal to 13. Now, we found the variable, but we still need to find the angle measurements. So KLN is 10x minus 5. So all you have to do is 10 times 13 and subtract 5. 10 times 13 is 130, minus 5 is 125. So that angle is 125 degrees. For this one, 4 times 13 plus 3, you get 52 plus 3, which is 55. And you can do a double check at the end. If you add those two measurements together, do you get 180? Yes, you do. So it works. All right, your homework assignment is on MathXL, and you need to show work for problems 7 through 10, and make sure you submit those in Canvas.